In this video, what I want to show you is something that we call our connectivity blueprint. It's a way to define and draw and describe how to deliver connectivity in challenging situations. And it's a set of diagrams and documentation that we use internally at Venn to help explain to the whole of the team what we've built, particularly when we build something a bit different and have to be creative in how we deploy the connectivity that's available. So in this example, I'm going to talk about a use case in Brazil, and this is for autonomous dump trucks running around an iron ore mine in Brazil. And the customer came to us. They are incredibly advanced technologically. They are really pushing the envelope as to what technologies they can deploy in this mine to make things more efficient, to make things more cost effective, and to deliver health and safety, which is fantastic to see. And what they want to do is have tele drivers of their autonomous vehicles that can be able to step in and drive those dump trucks as needed. And it's that kind of halfway house between full automation and teleoperation, where some elements of this dump truck can be fully automated, but there are times when we want to have a human in control. So they asked for this, the ability to have drivers in both connected via local networks, so wireless networks in particular, and we'll see those in a second, but also potentially remote drivers as well. So drivers that could take over if there was an issue on site or perhaps an absence. And they talked to us about what the real challenges here were, or what they were trying to achieve. And you can see that in requirements here. They needed low latency connection between obviously the drivers and the dump truck. They wanted to use any available network. There was no guarantee as to what networks would be available on the site. So they want to be able to combine whatever connectivity is available. And therefore, they want to be able to cope with a mix of different technologies and latencies, and they wanted to be able to use those links in the most appropriate way. And naturally, they're looking at Starlink or LeoSat. And what they want there is this ability to fail back or over to Starlink when there is a lack of connectivity, perhaps in an RF black spot on the site, or if something were to go down, they'd want to be able to recover that dump truck and stay connected to it and drive it back, or at least get data from it. The last and perhaps just as important as anything else is security here. They don't want anybody else to be able to take control of their dump truck, of course, so they want end-to-end security. Now, what were the challenges? Well, we've got them written down here. There were Wi-Fi networks deployed, mixed types, mixed vendors in different parts of the mine, and where there was coverage was very good. But coverage was patchy in pools. And because they don't have Wi-Fi everywhere, they started to deploy private cellular. And the private cellular solution varied depending on the site, and it was at times hugely successful, and at other times, because of the shape of the mines, was not as successful as it could have been. Now, of course, we can talk about private cellular later, and how we might improve that by extending the range of private cellular into different areas, which we can do over Starlink and over cellular, public cellular if it's available, ironically. But in this case, just understand that there were patches of Wi-Fi and patches of cellular. When they tried to use Starlink themselves to remotely drive the dump truck, they struggled with the packet loss and the variable latency and indeed variable bandwidth that you see on Starlink in quite a regular sense. And that impacted the latency on the video, and it's video latency that really impacts the ability to remote drive. As a remote driver, you lose confidence in the system if you get glitches in your video, or if the video suddenly is, high latency on one screen and low latency on another, you don't trust the system. So it impacts confidence from the teledriver perspective. So they wanted a solution they could test as a POC, and then they wanted something that could extend to multiple trucks on the site, 50 trucks potentially. So that was good, and this connectivity blueprint here explains how we delivered the POC. So This first page is the high-level conceptual overview, and then we're going to jump into the traffic flows, because whenever we design a network, what we need to understand is what traffic is flowing over that network and how to prioritize it, how much bandwidth that traffic is going to be using, and really get to the bottom of which traffic is important and which isn't. An obvious and perhaps ridiculous example is if somebody in the office is streaming YouTube videos or on Facebook or on TikTok, we don't want that activity to impact teledriving. Now, of course, some people will say keep the systems completely separate. I disagree. I actually think that we need to use every piece of possible connectivity on site in an intelligent way. So what we need to do instead is control traffic flows on the networks and make sure that our teleoperation links have the most bandwidth and the lowest latency as possible. So there's a bunch of different traffic sources here going backwards and forwards between the teleoperator and the archive logging server that's sat in an office and the dump truck and what it has on board. And the dump truck had compute, it had multiple IP cameras, and it's got a bunch of sensors. And the sensors are typically connected to the compute board, which is often today it's normally an AI-driven tensor platform. But in this case, I think it was something more simple, more straightforward, an industrialized PC effectively. Now, the sensors are interesting because the sensors are super important. Health and safety, we want to know if there's anything in our way, if there's any sort of low pressure on the tires, anything that would affect the truck mechanically. And indeed, the long-term plan, of course, is full big data approach to all of this, where you can sense when a gearbox might fail, or you can detect when there's an issue with tire pressure or engine noise and engine knocking, anything that might suggest that there's going to be or predict a failure in the future. When we look at the streams, if we work top down, we've got some messaging here, which is hosted on the PC and is bidirectional between the PC and the compute. We've got HTTPS traffic, and this is really for accessing the web interface on the compute device so that we can do management and control. That's important. We have VNC, well, that's doing desktop to that compute device from the PC. Important when we need to solve things, but not necessarily a continuous traffic source. Then we've got MQTT used for real-time messaging between sensors and the server and PC in the offices. And then we've got the big hitters. So we've got the video streams. This 554 RTSP streams, that's coming from the cameras on the dump truck back to the viewer, of course, but it's also being archived on the server locally for later review. So there's definitely some traffic there. And in general, we've got PC to compute module traffic. That's important. So we detail what these are, and we detail the ports, and that's because we can then identify that traffic by source or destination IP, and then we can treat that traffic in different ways. We can duplicate its packets and spread those packets across multiple links to ensure delivery. We can add forward error correction to infill for any sort of packet loss and deliver reliable streams of video. And we can also route traffic types, different traffic types, on different WANs based on latency. So we could potentially be in a situation where we favor low latency for video and have higher latency just for sensor logging, which perhaps isn't as important, or rather not as real time necessarily. So traffic flows is about identifying the flows and then the bandwidth, latency profiles, and then the priority of those traffic types. And if we know all of that, then we can design a solution that serves those traffic flows and make sure that they are reliable, redundantly delivered to the endpoints, and that the applications and user experience of the network is as expected. Once we've worked out the flows, we can then jump into network diagrams. So let me show you this, and let's go through this step by step. So in the middle here, we've got the dump truck, and we've got the cameras, compute, and sensors. And what we're doing is installing a BR2 Pro on this dump truck, actually a different version of the BR2 Pro than the one shown. The version we're using has got M12 connectors so that there's less chance of vibration affecting those links. but ultimately it's the same platform. And that BR2 Pro is quite a powerhouse. It can connect to lots of different network sources at the same time and use them intelligently. And so what we've got it doing here is we've got it connecting over Wi-Fi to those Wi-Fi APs that are around the mine. We've got its dual cellular connected, first one to the private cellular network on the site, and the second cellular is available to be connected to the public cellular network when it can see it. And then we've got it plugged into a Starlink, which is mounted on the roof of the dump truck as well. Now, that BR2 Pro can manage private, public cellular, Wi-Fi and Starlink, and keep track of those links, measure the latency over those links, and use those links in intelligent ways. The perhaps cleverest bit is that using Peplink technologies, we can use SpeedFusion bonding, where we can combine all of those links into a single logical tunnel between it and another Peplink device. So for this POC, I've got two more Peplinks in the design. The first one is here, sat in the local network office. So this is physically on the entrance to the mine, on the ground level, if you will, rather than subground. And then we've also got a remote teleoperator with a slightly larger device, Peplink device over here. What those are actually at this stage doesn't matter. I've got this down as, I think that's a 710 maybe at the remote site, and a B15G. At this stage of designing it, it's really dependent on how many devices are going to connect to it and how much bandwidth it needs as to which model you would go for. But for this POC, we've used the devices we have available. So if we look at the local office site, we've got the driver at servers and other PCs and devices, and that is physically connected to the private cellular network, but also the Wi-Fi access points and the Wi-Fi networks that are distributed around the mine. And what we're doing with this Peplink at that office is connecting to those private networks so that we can build a tunnel between the BR2 Pro and the office Peplink using SpeedFusion bonding over those two private circuits. Now that means that when the dump truck goes into a Wi-Fi area, it can use Wi-Fi. And when it comes out of the Wi-Fi area and it goes into a private cellular network, it can use the private cellular coverage. And when they're both available, it can bond them together and use all of the bandwidth and all of the connectivity that that's available over those links at the same time, which is brilliant. But as we heard in the requirements, there are areas where we don't have private cellular and where we don't have Wi-Fi coverage. So we needed another link. And this is where the Starlink and the public cellular networks come in on the truck. Using Starlink, we can connect to the internet, of course. Now, so long as the local office also has reliable internet access, and this one does because we've got a fiber connection and we're backing it up with a Starlink, then this BR2 Pro can actually create a single logical tunnel made up of public internet connections, the cellular and the Starlink, and private connections, and bond those back to the local office. Now, as we saw earlier, we want low latency and high bandwidth. So when we configure SpeedFusion, we're going to favor the low latency local connections, wireless connections, over a higher latency internet connection. But the beauty of this is when that truck goes out of coverage of those private Wi-Fi networks, it doesn't matter. It seamlessly fails over to the internet connections. And the only thing that changes in that experience of that video stream is a slight change in latency as it goes from local networks to public networks. The other thing we're doing with Starlink and indeed public cellular on the truck here is improving the way that traffic is sent over those networks. So we're treating the traffic with optimization techniques to ensure that any packet loss that might exist doesn't affect us and that we get great quality connectivity. Now, what about the remote site? Well, the remote site is connected, it's likely in an urban environment, and in this case, it's connected with dual fiber connections to the internet. And what we're doing is we're creating a bonded mesh effectively. The truck will connect to both of these sites during the POC, and have a bonded connection to both. And then we're bonding between the remote teleoperation site and the local one on the mine over all of the available public internet links as well. The end result then is, as we can see down here in this bottom corner, is we've got super redundant multi-WAN links between all of these locations. That mean that no matter where that truck goes on the site, so long as it can see the sky and with its Starlink, or so long as it has got some form of wireless connection, cellular, Wi-Fi, public-private cellular, whatever, that truck will stay connected to the teleoperator. That truck will be able to send sensor information back. It will be remotely controllable, and it will be reliably, safely connected throughout the mine site. Tab 4 is where we get onto the finer configuration and SpeedFusion configuration and routing, and I break that down step by step. I think we've had enough for this video. If you'd like to see that, let me know, and I'll do a separate video on the actual configuration of this, showing you how I configure SpeedFusion and the routing to deliver this in a successful way. Thanks very much.